In this video, I want to introduce you to polynomials and then what it means to talk about the zeros of polynomials and the inverses, some names for different pieces of polynomials, all right, and how to solve for not just what zeros are, but how to solve for zeros of polynomials, all right. So let's first define it. So a polynomial is an expression where let's number it. No variables appear in denominators. Okay, so let's get that clear. Also, all exponents are natural numbers. Okay, natural numbers are 0, 1, 2, 3, 4, 5, 6, etc., etc. All right, so let me give you some examples of polynomials, and then let me give you some examples of expressions that are not polynomials. Okay, for a number, okay, 2,687, those two numbers are polynomials. Okay, why? There's no variables in the denominators, and there's no exponents that are not natural numbers. Okay, single variables, x, y, and z, that's a polynomial. You can also multiply it by a number, 3x. You can multiply it by a number and subtract another number. You can even have a bunch of variables multiplied by different numbers, added and subtracted together. You can even have variables multiplied together. So how about a times b times c divided by 10 plus xy divided by 7. Okay, all of these are valid polynomials. Now the ones where I have division, those are fine because I'm dividing by numbers. Okay, so now let's put these aside and let's give you some examples of things that are not polynomials. All right, so we'll do these, maybe blue would be a good color. All right, so 1 over x, that doesn't get to join the polynomial club because you have a variable downstairs. Y to the minus 2, because you have a negative exponent. Okay, that is no good. A plus b divided by 5k. All right, it was good until we put the k in there. Okay, if we just put the 5 downstairs, we would have been fine. All right, let me fix the k. Okay, so now that we, and then let me give you some terms of polynomials. So the numbers that are in front of variables, we call those coefficients. Okay, so in the purple polynomials that I gave you, on the 3x, the 3 is called the coefficient of x. Below that, the 4 is the coefficient of y, and then below that we've got a coefficient of 3. The y has a coefficient of minus 4, so the minus comes along for the ride, if that's not clear, if you didn't know that. And then on the z we have a coefficient of 5. Okay, now let's do the one on the right. We can say that for ABC, we can say that the coefficient is 1 over 10. Now even though we are dividing, that's the same as if we multiplied by 1/10. That's why we can say that that's the coefficient. Likewise for the xy over 7, that's the same as multiplying by 1 over 7, so we could say that 1/7 is the coefficient of that. Okay, that also helps you to understand why the negative came along for the ride on the minus 4y. Okay, let me write minus 4y here in the highlighter. Okay, that is the same as adding. That's the same as adding the product of minus 4 and y, right? So if you can always convert a polynomial to have nothing but addition. I don't know if you guys knew that. So of course the numbers multiplying the variables will change sign, but that's the price you pay. So that's why we say that the coefficients are what it would be if you only had addition. All right, and then so that's, and then also let's the x, y, and the z by themselves. We know that multiplying anything by 1 doesn't harm anything. So if you like, you can say that the coefficient there is 1 for all three of those. Okay, an invisible 1 if you want to be cute, but that's what we say when there's no number. And also, so we call those numbers coefficients. Now, when we add, or the pieces of the polynomial that are added and subtracted together, the different pieces are called terms. All right. So the best polynomial to show this on would be the one at the bottom, the 3x plus 4y plus 5z, and then the one above. So the terms on the 3x minus 4y plus 5z. So the 3x is a term, the 4y is a term, the 5z is a term. Above that, on the 4y minus 2, the 4y is a term, and the 2 or the minus 2 is a term. And the one above that, 3x, that polynomial has a single term. All right? Now, another word that people will use is they'll talk about degrees. So the degree of a polynomial is nothing more than the biggest exponent. Okay? So, for example, I will put here a couple of polynomials. Okay, and we would say that the first one, we would say that it's second degree. Okay, on the second one, let me just make it a little bit more complicated. Okay, so once again, we ignore all the exponents except for the biggest one. And so the second expression, the biggest exponent is 3, so I'll say it's third degree. See how that works? And then the last one, we have lots of exponents, but the biggest is 5, so we say that's fifth degree. Okay. All right, so how do we find zeros of polynomials? So first of all, what is a zero? A zero is a value of the variable or variables that make the polynomial expression evaluate to 0. Right? So for example, 4x minus 12. Okay, the 0 has a 0 of x equal 3. Okay? Because if I replace x with 3, 4 times 3 minus 12 is 0. Now, some can have more than one 0. All right, what about, okay, this one has 2 zeros. Can you see what they are? Try plugging in 2 and try plugging in 1. You'll see that both of those make it equal to 0. All right. Now, as far as how you find zeros, one way to do it is to factor. Once you factor a polynomial, you know that one or more factors has to be 0. That's the main tool that you will use. So for example, on the second, what I would do is I would say, okay, first I'd factor it, if I knew how, if it was possible, and then I set that equal to 0. Now, the only way that a product, and that's what I have here, is each of those two blobs multiplied, whenever you have something multiplied together, that makes a product. So the only way that a product could be 0 is if one of the things being multiplied is a 0. Okay, so in other words, that means that x minus 2 equals 0, or x minus 1 equals 0. So x equals 2 or x equals 1. So that's the game. Now, it may not be easy to factor it. It may not even be possible to factor it. If you can't factor it, we need to hope there's, like the quadratic formula, that there's some other way that we could solve it. Okay, but in general, should be your first choice. All right. Now, if you have, for example, tools like a graphing calculator, you can graph it, and the zeros will be what? It'll be the x-intercepts, right? So you can see where it crosses the horizontal axis. That's a way with technology to also get the zeros if you can't factor. Okay, and then as far as inverses are concerned, we know how to find the inverse of a function by swapping the x's and y's and then solving for y all over again. Okay, now unlike for a line, when you have a polynomial, a lot of them are not invertible. Okay, so what that means is that you're going to have limited domains. Okay, let's do the simplest, or let's do one of the core building block polynomial functions. Okay, so for example, y equals x squared and y, well, we can do add linear also. Y equals x, y equals x squared, y equals that. These are some of those core simple building block functions we were talking about earlier. Okay, let's do the inverses of these polynomials if they have an inverse. So the first one, the inverse is itself, surprisingly. Okay, so that's the inverse. The second one has the inverse is the square root of x, but that one has a limited domain. The domain and range are limited, so you can't take the inverse of the entire parabola. You have to be happy with just taking the inverse of half of the parabola. So if we confine, let's say, the parabola to x is greater than or equal to 0 only, if you agree to limit yourself to that, then for that half parabola it has an inverse equal to the square root. See how that works? Okay. And then for the y equals x cubed, that one, the inverse is x to the 1/3. That one can be positive or negative. All right, so we're good to go on that one. All right. Now for the last one, I'm trying to think if you're going to have an issue at x equal to 0. So that's the only place you would have a problem. But no, I don't think that that's a problem. So yeah, everything's good.